Hi, my name is Will Kane, and welcome to Crash Course Quantum Physics. Today we'll be learning about string theory. And string theory is honestly one of the hardest things to wrap your head around, so bear with me.
Doesn't string theory mean like everything's made up of strings and stuff, like Interstellar?
Well, Miss in the past, that's close, but like usual, not quite right. String theory says everything is made up of little tiny filaments, or strings. These tiny filaments all kind of vibrate together, and these different frequencies create different elements, well, what are actually elementary particles, but we'll get into that later.
Now let's go to the thought bubble. So I hope everyone at home knows about these things called molecules. And I would also hope that everyone knows about these things that are even smaller, making up these molecules, called atoms. After studying these for so long, scientists found something smaller, called an elementary particle. These are the smallest things in the universe. However, this means they can't measure them exactly. Now this leads us to the Heisenberg uncertainty principle, which states that we can't find exactly where they're at. Now this is the basis of all quantum physics. So let's talk more about these particles. So this is where we find out about the point particle, which is what we call these particles when we use exact distances and locations for them so we can use math involving them. Quantum field theory is how we measure these interactions. Now this is studied so much that scientists have it all down to a science. Get it?
This is where things get tricky, because of our old friend gravity. Not only did gravity wake up Sir Isaac Newton from a great nap under an apple tree, it also caused physicists to fail the math portion of their exam. Now, gravity doesn't fit in the math used in quantum field theory, which only allows for exact distances between 2 points. Which gravity clearly doesn't have this. So to marry the standard model of quantum physics and gravity, we have to create a fictional, way more complex system that doesn't use a point. So they decided to use strings, because they're a little more complex. All these particles, or now lines, have their own vibrations, like a stringed instrument. And just like how different vibrations on a guitar can give you different sounds, the different vibrations of strings give you different particles. The best part? This includes gravity. Now, it doesn't work quite like the 3 dimensions we all know and love. You know, the ones that go up, down, side, and forward and back? Well, this takes 10 of those dimensions. Now, this works mathematically, but because we don't know about 10 dimensions, this hasn't been proven experimentally. So what's up with learning about all of these different imaginary strings? Well, the math works, which is a very important part of science, but specifically with quantum physics. String theory is also the best way to figure out problems in the quantum world, like wormholes and black holes and what's happening to antimatter.
Oh, look what time it is. It's time for the open letter. But first, let's check what's under the magic book. Oh, strings! Oh, magical strings that hold the universe together. Thank you for making everything just how it is. But why do you have to be so dang complicated? Best wishes.